Hey everyone, welcome. Azure Cosmos DB live TV. Oh, here, let's start like this. I hate starting with slides. I'm Mark Brown, and I've got with us this week Sajee. How are you?
Hey, Mark. I'm doing well. How about you?
Good. I like your background there. I'm gonna
Yeah,
get you. I'm gonna
I got
get you.
inspiration from your background. Actually, I
Yeah.
have a virtual thing.
Okay. Thank you. That's great. I'm glad I inspire at least something. Logo usage, if anything. So hey, great to have you on. We're gonna
Thank
talk
you,
about
Mark.
something that's been in the works for a little while, and also pretty cool as
That's
well.
right.
I'm really excited about what we're going to talk about today. So I don't want to waste any time teasing folks here. Let's get right to it. But we announced, I guess, just recently this data API builder for Cosmos. In fact, it wasn't just for Cosmos. We got it for SQL DB,
That's right. For all the Azure
I
databases.
think, and Postgres. All the
Yep,
Azure databases.
that's
Really?
right.
So we've got it for
Yep.
things like Kusto as well?
Yeah, I would say Azure SQL, Cosmos DB, and then MySQL and PostgreSQL.
Okay, so look more of the operational
That's right.
databases, right?
Yeah.
So, okay. Cool. Yeah, this is really exciting. I know people have been asking for a feature like this for quite some time. And it's really nice. I've gone and taken a look at it, and I'm pretty excited. So I'm really excited for us to talk about it today. So hey, I don't want to. Let's not hold anything back here. Let's get right into it.
Thanks, Mark. Yeah, we announced this last week, and we have been getting a lot of positive feedbacks, especially from the developers since we have the integration with static web apps. And yep, let's get started. So, outline for today is I will talk a little more about what is Jamstack and GraphQL, because that lays the fundamental for this particular session. And then we will go into data API builder overview. What is it all about and how to get started. And I will talk about the tool set that Data API Builder provides, including the Data API Builder CLI, and also we will talk about the Data API Builder features. And finally, I will show an end-to-end demo with integration with Azure Static Web Apps. And if you have any questions, we will address them as well.
Oh, I'm gonna just bug you the entire show with questions, Sajee, just to let you
Yeah,
know.
definitely. Would love to answer them. Yeah, just to start things off, Jamstack has been a buzzword in the whole developers ecosystem over the years. You may call Jamstack as an architecture that is based on three fundamental concepts that developers use on daily basis. It boils down to three basic principles that developers are aware about. One is JavaScript, and then APIs and markup. So this is what Jamstack is all about. And if you look at the workflow, just to see the difference between a typical web application and a Jamstack application, I'm sure all of you have heard about WordPress. Let's take WordPress as an example. Assume when the user hits the index page, what happens behind the scenes is that a PHP file gets called, and then the SQL queries are made, and then PHP file generates the HTML on the fly. That's what user sees it on the a browser in a traditional web application, as an example. In case of traditional web application, developers have to write the code and deploy to a server. And when the client invokes a request, the request gets served and get acknowledged from the server. When it comes to Jamstack application, we can think of a single page application, which is quite popular these days with popular frameworks like React, Angular,
Yep.
or Vue.js. So in this type of application, when you do a build, what you're going to see is static content in the form of HTML and CSS. Apps that contain the static files are served through a CDN, which initially loads the static content in the form of HTML and CSS. And then the data is loaded through an API, which makes things faster. So it provides higher security because you can integrate with any of the authentication frameworks, or you can use with access tokens. And then it's cheaper and easier to scale because it comes with some of the offerings like serverless. And finally, better developer experience because it provides the CLI and more tools to test those scenarios. So that's the fundamental difference between a typical web development and a Jamstack. So we are targeting through this data API builder, we are targeting those type of audience, I would say. We spoke about Jamstack and three fundamental concepts. Let's talk about the term API itself. So I'm sure everyone knows what API stands for. When you think of modern applications, these are the two fundamental concepts that we have been widely using or among the developers which have been widely used. One is REST and then GraphQL. I would talk about the differences between these two. REST has been existing over the years And the adoption of GraphQL has been booming in the last recent years. Just to elaborate more on these, the difference between these two, assume, say, we are building a Cosmos DB live.com, or which consists of speakers and the sessions associated with them. And if you're using REST as example, what you would see is like the URL which contains the speaker's information. But behind the scenes, if you see, when the user accesses this page, we are getting the information about the speaker and then the particular sessions that he has done and the demos associated with. So basically, we are invoking three REST requests in order to build this particular front end. The request would look like initially you would make a call to get the sessions associated to the speaker, and then that would send a JSON response with a whole bunch of information, including the data that you don't need as well in terms of front end developers. And then you would send another request to get the demos, which needs to be shown on a separate tab. So it's additional payload that is that has been invoked. So it in terms of the request, it's also one more request that you're sending. So if you look at the page that I showed, it makes three requests. First, to get the speaker, which consists of bunch of information, and then you are fetching the sessions, and then you are fetching the demos associated with the user. So this, if you really look at with REST, you try to make three requests to different endpoints to fetch the request data. Another issue is that we underfetching and the N+1 request problems. I hope all the database developers are aware of this. So underfetching really means that a specific endpoint doesn't provide enough required information. The client will have to make additional requests to fetch everything needs. This can escalate to a situation where the client needs to first download the list of elements and then make another request to get set of data that needs to be shown on the front end. So the overfetching and then the number of requests and the payload size also gets increased with this type of. So the backend developers tend to write custom APIs to solve this problem. You can embed these three requests as one and then provide a single endpoint. But again, that's going to be complex, right? So when you when you have to address different scenarios for mobile, for different type of devices, you have to make changes back and forth. That creates a hassle between the front end and back end developers. So it creates an inflexibility in the REST endpoints to keep up with the rapidly changing requirements of the clients that access them. This is where the GraphQL was introduced back in 2012, which resolves some of the issues that we currently discuss. So yeah, the point that I talked about, different devices, different platforms, you can build with GraphQL. So in GraphQL, on the other hand, you would simply send a single request to the GraphQL server that includes the concrete data requirements. The server then responds with the JSON data where these requirements are fulfilled. So I will show the same example that I showed in the previous REST example, right? So just to set up the context, it's a query language for your API, and it allows creation of semantic layer over the data or the database sources that you have, which basically abstracts away the underlying data structure. When you send a GraphQL query to your API, what you exactly get is what the front end needs or what you actually require, nothing more than that or nothing less, which solves the N+1 problem and also the overfetching problem that we discussed. So GraphQL queries always returns a predictable results. So you take control. I mean, the developer will take control of the data that he needs. So apps using GraphQLs are usually fast because of the fact that they control the data they get and not the server which controls the data. And also the number of requests are typically reduced when you make GraphQL requests. So one of the advantages that GraphQL provides is that you can combine multiple data sources as well as multiple REST requests to a single GraphQL endpoint. So you can read more about what is GraphQL in the GraphQL and the GraphQL spec in the GraphQL org. You can go ahead and explore. This same example that I spoke about in the REST scenario, the Cosmos DB live.com scenario that I spoke about, that particular three requests can be made into a single request, which consists of the query, graphical query like this, where I'm fetching the information about the speaker Sajee with what are the information that I want to bind it on the front end, say name, handle, and the list of sessions and the demos that I want to show it on the front end. So, and the response would be something similar to this, which contains information about what the information I need to bind it on the front end. So that's the advantage that I spoke about, GraphQL over REST. And if you have to speak about GraphQL core concepts, Mark, do you have any questions before I jump into?
No, this is great. I appreciate you giving the audience a primer kind of on GraphQL and kind of its advantages for people that have not used this or seen this before. No, I think this is great. I don't have any questions. I just keep going.
All right. So when you talk about GraphQL core concepts, basically 4 concepts that comes into mind or that typically developers would deal with. First one is the schema. I would explain each one of these in quick time. And then the second one is queries, mutations, and subscriptions. Currently with Data API Builder, we don't have the subscription functionality, but we will be adding it soon. I will explain what this subscription is all about. For example, the schema, right? The first fundamental concepts. GraphQL schema defines the structure of the data that you want to play with using the GraphQL query. You can assume when you're dealing with databases, the schema term would be very familiar. Usually GraphQL server uses the schema to describe the shape of your available data. So in this example that I'm going to show today, I'm using a simple Cosmos DB collection called Wonder, which consists of different data types in the form of string, and then ID and things like that. So you can assume schema as a structure of what the data you want to play with. So definitely this supports different data types. You can explore more in the GraphQL.org website. And the second one is the queries. Queries is another fundamental concepts which basically describes what data you want to retrieve using the declarative format. So in the example that I showed earlier, you can see I'm querying a list of wonders with ID and name. Basically, we support the pagination as well. I will come to that later. But you can see this is a structure that we are defining in order to fetch, the collection or which is existing in the Cosmos DB account. So this is just an example of query. Basically, it is equivalent to in the REST scenario, you can think of GET operation. So you actually fetch some information from the backend. And then mutations is the third concept which I talked about, which actually deals about making changes to the data. Say if you do any create, update, or delete to the existing item, or if you want to create a new item, that is called as mutations. So in this case, I'm creating a new item using create wonder method. So I'm passing the, um, data that is required to insert into the database. And the final one is the subscription. Subscription means, so whenever you changes any data in the database, which actually get notified to the front end. So that is called as subscription. You can think of different, if you have to provide an analogy, you can think of Twitter as an example. So if you are seeing those tweets, those can be considered as queries. And then if you are creating a new tweet with several hashtags, that can be called as a mutation operation. And if you're following someone, and then if you're seeing those notifications on your feeds, that can be called as subscription. So these are the different fundamental concepts that is exist in GraphQL. Now coming to the core part of this session. So we spoke about what is Jamstack and GraphQL. I hope you got a basic understanding of these two terms. Let's jump into the Data API Builder feature or the tool set that we have recently announced, which allows the customers or the developers to instantly and securely build a GraphQL and REST endpoints on top of Azure databases. The goal of this tool set is to make sure you can access the databases, Azure databases via REST and GraphQL endpoints, which means it also provides a better developer velocity in building full stack and Jamstack solutions and to make the data more easily accessible. Data API Builder automatically generates REST and GraphQL endpoints based on the provided schema and the configuration file. I will explain each of these in detail. Basically, in terms of Cosmos DB, we support the GraphQL endpoints on top of NoSQL API. Currently, NoSQL API already have a REST endpoint, so the REST endpoint is not supported through DApp, but you can enable GraphQL endpoints on top of Cosmos DB NoSQL API accounts. So with Data API Builder, data objects can be exposed via REST and GraphQL endpoints. So your data can be accessed on any platform or any language or any device. That's the point I fundamentally talked about in the earlier slides. So Data API Builder provides a superior developer experience with a great tool set, CLI, which I will dive in. It simplifies the client-side code and enables rapid development for the developers to simply scaffold the application and deploy to any environment that they need want to deploy. If we have to talk about the architecture of the data API builder, this is the end-to-end experience. So the developer has to provide something called as a configuration file, which contains the metadata about the entities, the database that you want to access, and some of the developer experience that provided as metadata. And then for Cosmos DB, you have to provide a additional file, which is called as a schema that we described earlier, which is a structure of the the collection that you want to access. So these are the two files that developer would typically need to provide for NoSQL databases such as Cosmos DB, and for relational databases, this schema is automatically fetched by the engine itself. So once the provides the schema and the configuration file, we actually can perform REST or the GraphQL operations on top of existing databases. So that's the.
So I got a question for you then. Since you have to provide this schema,
That's right,
for NoSQL database like Cosmos,
that's
does
right.
that imply that you have to have a fixed schema for that container?
Right now, it has to be fixed because that has to match with the collection. But we are thinking of adding a on-the-fly experience so that whenever it changes the schema, that would be automatically exposed to the data build runtime. So
Okay.
that you don't have
But
to
right
worry about.
now, if you were mixing entities into a container, you wouldn't be able to use GraphQL, basically, right?
You're adding a new entity means you have to add a new data model in the schema. Then you would be able to use it.
So you could support this, or it could work. You just add a separate
That's right.
data model for that same
That's
container.
correct.
Okay,
Yeah.
so you can mix entities and use this. You don't
That's
need to
right.
have a fixed schema.
Yep.
Okay, all right, cool.
All right. We have gone through the architecture. So the DAB is available in two modes for the end users to consume. First way is that we have open sourced the engine itself. So if you want to make contributions, you can certainly go to Data API Builder. Mark will be sharing the link, and then we have opened up discussions. We have opened up open source contributions. So feel free to contribute to any of these missing scenarios on different databases, especially on Cosmos. And then the first one is we are providing a self-hosted way to run the DAB engine, where you can host it on your local environment, or you can host it in as a container, or you can host it in any of the other environment that you want to have this runtime to be able to run, right? The second version is that we are offering a lightweight, low maintenance, and high performance technology, which is very useful to developers, the Jamstack developers, which is spoke about. We are the static web apps integration so that end users can spin up the GraphQL endpoints in QuickTime. I will show an end-to-end demo for that. So these are the two available modes to consume Data API Builder currently. And the other tool set that I explained about earlier is that Data API Builder CLI, which provides a way to generate GraphQL and REST endpoints if you are running it locally by providing the config file and the schema file. So since it could be cumbersome to some developers to manually generate those config file, we have come up with this CLI with few commands. I will show that in QuickTime, which makes better experience for the developers to have the Data API Builder to be able to generate GraphQL or REST endpoint. Let's look at some of the getting started.
Sure. So this
commands.
config is kind of analogous to like a Swagger spec, basically, for REST.
That's right.
Yeah. Okay.
Yep. So yeah, I have already explained what this Data API Builder CLI is. So it's a command line interface which comes with some of the commands such as initialize, add, or update entities or their permission. It gives the flexibility for the developers to control what they want to expose through the REST and GraphQL and the supported commands you can see. So this would be the experience. So the developer, you would use a DAP CLI and init the config file using the init command, which generates the DAP config and the schema file. And then by using these two files, you can perform operations on the existing database using REST and GraphQL. So which comes with certain operations: add entity, update entity, delete entity, and then finally you would use dap start to start the engine in your local environment or any other environment where you want to host. So the point I talked about, two files, right? One is the configuration file and the other one is the schema file. So the config file is a JSON file that consists of these information. So you can talk about the backend database, which where you want to enable REST and GraphQL endpoint, and then the runtime settings, which is very developer friendly, and then the entities that you want to expose, and the security rules that you want to enable on those entities. And if you are dealing with relational databases, you can configure relationship between those entities, and then you can also define a mapping for those entities as well if you don't want to use the existing database table names or the collection name. And then if you want to configure specific configuration related to each of these databases, so we have provided a specific config section for each of these databases. I will run into the config file in quick time. So you can see a sample config file. You can see this is for Cosmos DB NoSQL API. So you have the database type as Cosmos DB NoSQL, and then the database that I want to access to, and the schema file. So in this sample, I have named it as static web apps database.schema GQL, which consists of the schema file. And then connection string, basically, you can use the environment variable, or if you are dealing with emulator, Cosmos DB emulator, you can replace this with localhost. And then these are the runtime settings. So for Cosmos DB, we have enabled GraphQL by default. And then if you want to change the GraphQL endpoint, you can make changes to this endpoint. And then we are allowing the introspection. So basically, for the developers to go and see, okay, what are the operations supported and things like that. And then if you're enabling development mode, we are also providing a way to open the GraphQL endpoint locally so that you can navigate and test it in the browser itself. Like it will, if you access the local host of port 5001, then you would be able to access the GraphQL endpoint in your browser and then test it immediately. And then we are also providing an authentication provider. So either you can use the Azure AD or the Azure Static Web Apps to enable the authentication mechanism when you are having the integrated, or even when you host your static web apps. And then this part is important. So the default init command will generate a config file like this, and this entities section you have to manually add it, because there would be a number of entities for each each database. So we are letting the developers to add this manually, or you can use the dap add command by providing the entity name and the set of permissions. So in this case, I am defining a role as anonymous, so that user will have all the actions like read, update, delete, create, all the actions enabled on this particular one-day entity. But if you want to restrict based on the role, say if you have an authenticated user with certain permissions, you can change the role, and then you can enable the actions of certain fields as well. So I will show a quick sample file for that as well.
So I get a question on the authentication on Auth there. So you said it supports Azure AD as well as the static web apps in there. Okay, great. And that's using the Azure identity?
That's right. So I will come to that part. I have a slide for that.
Oh, okay,
basically,
cool.
It uses the, these are the commands. I have just provided a sample for each of these, dab init, Cosmos DB. So this will, maybe I can quickly show a demo for this. Like in this one, let me create a new file with the dab init, so that, we are creating the database type Cosmos NoSQL, and then providing the schema file, schema GQL. So basically, it will generate a config file. Let me open this in VS Code. So you can see the config file, which is already created. So this is what I was talking about. So basically, if you want to replace the connection string, you can replace. So I'm going to use a live account. I would have to regenerate the keys, but for this demo purpose, I'm connecting to an existing account, and then you can see this is automatically generated through the CLI. I have spoke about these properties earlier, and then the schema file. So this I have already created. You can see the type wonder with certain fields. And if you want to experience this development in the local environment, what you would do is you would just say you can explore the command using dab help, which has the list of commands. And then if you want to start dab in your local environment, you can do with dab start, which will pick up the config that I have, dab config JSON and the dab the schema GQL file, and then it will run in local environment. So right now, probably missing something. Okay, I think I have to save this. I didn't save. I am in the Cosmos DB live. Okay, the port is already in use, so I have to kill the port. Cool. Let me start. Cool. So that you can see the dab has started in localhost 5001. Now, as a developer, if you want to access your GraphQL endpoint, right now I have not configured any entities, but I'm just showing the developer experience so that. So the GraphQL endpoint is running. Now, if you go back and add entities to the entities in the config file, basically I'm replacing this with the collection that I want to access. So I have a collection on Azure Cosmos DB. You can see, like, if you go to Data Explorer and then particular, yeah, I guess this one. So I have this wonders collection with probably less items, which is basically the list of wonders in the world. So yeah. Now, if I add this configuration under entities, and basically we are telling that, okay, all the users will be able to do all the operations. And if I stop this and then restart again, I should be able to play with this REST endpoint or the GraphQL endpoint. Okay, I have to kill the port again. This thing.
Almost live show here. Even on a pre-record, things always happen around here. So, yep. How do you deploy while the thing's running or getting started? So, how do you deploy this thing? Is this just deployed as a container? It's a runtime. How does this thing?
Yeah, right now I'm using the NuGet package, which is provided as a. I mean, the engine itself will come as a NuGet package so that you can run on any environment. We also provide the container registry. I mean, the container registry URL, which comes as the image, so that you can download and then run it on any environment you want.
Got it.
And then if you want to deploy to Azure Static Web Apps, you would use the Static Web Apps CLI and then do the git push so that it will get deployed to, it will get pushed to GitHub, and then I will show a quick demo on that as well. So right now, so the endpoint is running, and if I access the localhost, you can see the endpoint be able to access. And if I do a GraphQL, you can see the banana pupcake ID, which basically lets the developers to test GraphQL endpoint. So basically, yeah.
Yep. No, go ahead. Yep. So that's the UX for this thing?
That's right. So on the local development environment, you would be able to see this interface. Basically, there are a lot of interfaces available. I mean, GraphQL, and then you can use Insomnia. You can use Postman to play with, a GraphQL endpoint. So in this case, if I run this one, I am testing my local endpoint, and then you can see I'm able to query a particular wonder using the partition key value and the ID. And then if developers are not, so this is what a data API builder automatically generate for you. So you don't have to write a single piece of code, right? So you can see the operations such as query, which is basically querying by partition key. And then if you want to get list of all data, then you would use wonders, and then basically you would use this particular example to query all the information. So it comes with pagination support. Basically, I'm having only less than 20 items, but if you have more than 100 items,
can you zoom that in a little bit so we can see a little better?
Yep, sure.
Is it possible?
Yep. So the has next page will be true if you have more items, and then you will get something like a continuation token. We called it as end cursor, and then that has to be passed with the next request. And then you can perform mutation operations such as create as well. Probably I will have to rename, otherwise you will get an error saying that it is already existing. So it will create a new item on the database as well. So
How does the
we support.
pagination support work with, say, continuation tokens within Cosmos? Do you have to manually
Yeah, that's
wire
right.
that up, or is
No,
it all?
basically it's built in. So basically, if you have more than 20 items, and then in this case has next page will be true, and then you will get a cursor. Basically, you have to pass that with the next request.
Got it. Is that configurable, the number of items per page at 20, or?
Yeah, you can basically configure that.
Okay.
Right
And
now
then it
it's
knows how to basically set kind of the max item
that's right.
response
Yep.
in our SDK
It
for the
works
backend.
similar to how our .NET SDK works as well. I mean.
Got it. And then just basically flows a continuation token back and forth, and then
That's right.
you just keep passing that back to get more pages.
Yep.
Okay. Yeah. Cool.
So I have shown the local developer experience using the CLI and how to spin, GraphQL endpoint on top of Azure Cosmos DB. So just to talk about the GraphQL data API builder engine, we are leveraging something called Chili Cream GraphQL platform. They have built a component called Hot Chocolate as the internal GraphQL engine. So it's open sourced. We are leveraging, the data API builder engine to host the GraphQL schemas, process GraphQL requests, and generate payloads for different clients using this particular library. It is built by one of MVP, data MVP. This has seen number of adoption, and he has mentioned this is one of the missing feature on his library. So adding this would bring more developers to contribute as well. So that's
where did he come up with these names? Was he hungry at the time or something? How is this very food oriented stuff going on here? So making me hungry.
Yeah. Mark, you asked about authentication and authorization. I would quickly jump into that. Data API Builder provides the ability to protect those endpoints and or keep them public. Public means users who are not authorized can still send a request and get back the data. If you prefer to have the protected endpoint, which means enforcing the data to user to get authenticated and authorized, you can enforce that on per entity level, or it means the collection level on Cosmos DB, or you can have a separate controls to enforce what access can be enabled on each of these entities that I spoke about. For authentication, we would require the user to create, go to an identity provider like Azure AD to issue them an access token. Essentially, they would provide this with the request, each request that they're making on Data API Builder. And this allows us to validate if they are authenticated users or not. Similarly, we are the Azure Static Web Apps integration. Static Web Apps provide an easy mechanism to externalize the identity provider configuration. So you can basically create those rules. So the data API builder doesn't need to be aware of the identity provider that the user is using. We are just depending on the authenticated user metadata information that is passed from the static web app. So that's the functionality that data API builder provides. Additionally, on the authorization side, access token contains different information, which I spoke about earlier, role membership information or users which are defined at the identity provider level. Also, it detects, dictates the level of user roles based on the user roles that you have created based on each entity that you want to access. So this is how we are enforcing authentication and authorization. Earlier, I went through the configuration file, but if I have to explain the authentication and authorization part in detail with specific to authentication and authorization on the config file, we have our top level entity, which is the entity name. It is assigned a set of permission, which you can see. Each permission is essentially a role and operation it allows. For a given role, you can define read, update, delete, as well as for each of these operations, you can define field exclusion and inclusion. So if you have multiple fields, and if you want to say, if you're performing read operations, and if you want to include all fields, then you can put a star. And if you want to exclude, say, name in that particular request, you can use the exclude metadata tag to exclude those fields.
So maybe you said this earlier. So if I've defined like RBAC policies on data in my database or containers or whatever like that, how do they get picked up by the stab CLI and then brought forward into these config files, or do I have to?
Yeah, definitely. So whenever you make a request, you have to provide the role. So I will come to that. So this is the part I will, yeah. So you would have to provide a user access token and API role. So based on this, we would validate the token and get all the claims that particular token has, which defines the rules. Okay, what are the roles that particular access token contains, whether the user has access to read, these specific fields or not. So it's based on the token that is generated once you authenticate through static web apps or Azure AD.
Got it.
I hope that clarifies. Yep.
Yep.
Okay. Yeah, if I have to talk about policy, which is like, so I already spoke about role, actions, and then if I have to speak about policy denotes, a further item level conditions to restrict the result set that are written, especially this defines, okay, if you want to filter database value based on the authenticated user ID, you can certainly perform. Say, if you have an ID with the user email or like something, then if you want to filter based on that claims that we get from the access token, basically you can do that filter as well. So it provides additional item level conditions if you want to enforce on the collection that you want to access through the GraphQL.
Got it. Yeah, that's cool.
So yep. Apart from the access token, developers also, the client application which uses the data API builder endpoint, specify the XMS API role, which is actually the specific role that you would define. So the application that is invoking the data API builder endpoint that is returning the data. Say if you are building an e-commerce application and if you want to provide certain access to certain users on the front end side, basically you would pass this API role and then restrict the information that you want to show on the front end using this as well. So that is the additional. And finally, I wanted to show the end-to-end experience, the integrated flow experience for the developers with static web apps. As I have explained, the first one is a self-hosted scenario, which I showed it in local environment. We are also providing the integrated experience to static web apps, which offering a lightweight, low maintenance, and high performance integration with static web apps so that you can quickly spin up data and data API builder endpoints with a few clicks. So Azure Static Web Apps provide a way for the developers to build and ship things faster. This feature is enabled on the Azure Static Web Apps in the portal using a feature called database connections. So let me quickly jump into that. So just to set up the context, I have an Angular app, which is one of the popular frameworks. So basically, I have built this Angular application, which lists the wonders. And then I have connected. So basically, I have the configuration file, which talks to the entities, wonders, and then I have the schema file. And then if you look at the code, basically just I need to pass the GraphQL endpoint. And then when you use the SWA CLI, you can use the same command as SWA init as well as SWA DAP connection so that you can test it in locally. And then once you push your code in GitHub, basically you might have already known how static web apps works. So this is my GitHub repository, and then you can see the SWA DB connections, which consist of the two files, database config as well as the schema file. And then you can actually see the workflow, which is enabled through GitHub Action. So which will build the Angular application and then enable the static web apps integration with data API builder so that the GraphQL endpoint would be generated. So if I go to static web apps, which I have already created, so this is the point I was talking about, database connection, which is in preview. And if I have to, so I have pushed my code to GitHub with all the configuration. Now I need to select the database type using the link existing database option. So in this case, we are going to deal with Cosmos DB for NoSQL. I will select Cosmos DB for NoSQL and then select the resource. So in this case, it's my resource group. And then I have to provide the resource name and the database name. So that's it. And then we are providing different authentication type. Basically, you can use the connection string as well as the managed identity. Basically, this is enabling the enterprise customers to use this feature in production. And then I can acknowledge the step and finally link. So what it will do is it will link the database and it will show the information here. So once it is linked, you can actually go to this blade and see the database that you have configured. Say if you have wrongly configured the database, you can unlink and then relink it again. And the two files are basically can be viewed from this blade. So you can just open it on GitHub, and then say if you want to make any changes, you can change on GitHub and then commit. And then similarly, the schema file is also enabled. So before I have this integration done, you would see an empty page like this because I don't have any database integration done. Right now, I have linked the database. So basically, I will refresh and see if the data is getting fetched, hopefully. Yeah, you can see the list of wonders getting populated. And if I debug this request, what you would see is basically the request to, the data API builder. If I go to network tab, and then there should be something called GraphQL. So you can see the GraphQL query and then the response being passed. So that's the whole integration demo. So it is very easy for developers to perform, say, a query. You can add a new entity. You can do a search. You can do a filter using the GraphQL. So all these features are supported out of the box with database link connection. So that's the feature I wanted to demo as well. Any comments?
Very nice, very, very slick. The way that's put together with the static web apps service.
That's right.
There. Yeah, like it. Very, very like it. Right. So and just
thank you,
man, easy to change. Just git push any changes you're going to make in there, and then so the dab CLI will just or dab runtime just picks that up automatically. Then
that's right. Yeah.
Okay. Boy, that's just can't
So
get any
that experience is provided through this hosting platform, which we have
Yeah.
already, it's not exposed to public, but this is how it works. So when the user push the code change, it will picked up by static web apps, and then static web apps makes those requests to our gateway platform, which basically hosts the dApp container, and then users would be able to execute REST and GraphQL endpoints. So this is a whole experience that end users would see, and then you can access any of those databases which I mentioned about. Yep, that's all I wanted to demo today. I hope it was useful.
This is great. I guess a few questions I got. Can I configure multiple databases at once with this?
Right now, it's not supported, but that is one of the feature. We have got as feedback, but definitely we would add that feature because, right now it's not supported. So it is supported on single database, and on Cosmos DB, basically you can't create a query which fetches the information across multiple containers. So you have to go with you can create multiple containers, but each GraphQL query has to deal with single container. So that clarifies, I guess.
Right. Yeah. I didn't mean to suggest you could do cross collection queries. That would we kind of frown on that sort of thing in Cosmos. But okay. Yeah. So, but you'd have to have a separate config. Basically, what you're saying is you can't do multiple databases. Even if the queries were separate, you still can't do multiple because there's only one connection per configuration. It's
correct. Yeah.
Okay. What's coming next for Data API Builder? Anything coming down the road you can share?
Yeah, basically, we have open source a repo, so we are getting feedbacks. Actually, if I have to show, we have already got a good number of feedbacks for Cosmos as well. So there has been a feedback to add, so if developers who are watching, if you want to contribute, you can just navigate to Data API Builder, and then we have opened up discussion, so you can see some ask already for Cosmos DB triggers, and then Cosmos DB Mongo API support. So yeah, basically we are going to open this discussion forum to everyone, and then we will pick up, based on the upvotes that we get. So if it's something that is blocking the customers to use in a production environment, we would prioritize those. But right now, we also have published the roadmap in GitHub, so you can go and watch the roadmap that we are enabling on Data API Builder as well. So I would request everyone to navigate to this, and also you can create issues if you find anything, so that we would be able to address as well.
Yep. That's great. I got the link up there for the source. That'll take you to everything you're looking at up here on the screen there. And then also just kind of wanted to share your announcement here as well.
Thanks, Mark.
that just came out on the 15th. So just very recently. What was that? Thursday last week, I think. So
It's on 15th.
I can't remember how many days it was, but just recently. And so, there you got all your shipping vehicles there. Where can I get links to those? Do I have to? Should I go back to? Should I go back to the source here? Can I get links to them from here?
Yeah, definitely. I mean, I have the links here.
There you go.
Yep.
Yeah. Okay.
So you can use any of these links. So basically, this is the announcement about Cosmos DB support, and then we have the Git link for Data API Builder, documentation, the samples. So we have put up different framework samples with different databases. So this is a good place to start if you're a beginner. And then finally, the database connection with Cosmos DB.
Yeah, the tutorial. I put up a link for that. Yep. Since people can't, at least not today, click on a thing on their screen and have it take them somewhere. So this is great stuff. Really exciting. It's amazing how, I mean, this is just kind of an evolution of doing data access and just how much simpler things have gotten. Now it's just, I mean, man, you could roll a data enabled web app in minutes, it feels like, right? I mean, it's that you got your data, just go and, I mean, especially if you're going through the static web apps interface there, that's just incredible how simple that is.
Yeah,
you know, and with the security built in. So yeah,
that's
sorry.
Right. Just to sum up, like if any of the audience have feedback or anything that we want to add, feel free to ping any of us so we can ping them up. And thanks, Mark, for having
me. Right here to this GitHub repo /Azure/Data API Builder, and then they can go and enter in feature suggestions on the issues list there. Go and check it all out. Yeah, this is really great. Well, hey, Sajee, this is really fascinating. I'm glad you were able to come on. I think this might have been, is this your first time on?
Yeah, this is my first time, but wow. I'm looking forward to more sessions as well.
Amazing. Okay. Yeah, we got to have you back because you're working on cool stuff. So we got to have you back, right?
Sure.
So, and definitely have you come back.
Features. Yep.
Yeah, and definitely more stuff with this thing. Got to have you back. Right on. Hey, thanks, folks. I think that's it for this week. I don't remember what episode this is. Oh, wrong one. But we've got lots of episodes in the can. Come check us out, aka.ms/CosmosDB Live TV. Also, our user group, monthly user group here, aka.ms/CosmosDB user group. And that's it. Sajee, thank you so much for coming on. It's great having you.
Thanks, Mark, for having me.
So, all right. Cool, folks. Thank you so much. We'll see you all next time. Thank you.